So you're probably wondering right about now, how much torque is enough torque? Is there a certain maybe foot-pound range or inch-pound range? Well, that's a very interesting question. Um, in this case, this is not a totally perfect compression fixture. There is a spec for how many pounds of force per square inch you're supposed to have in this compression. But here's kind of how this works. If you have zero compression, that's the worst. If you have too much compression, that's the second worst. Now, there is a very fine line that's the perfect amount of compression for maximum cell life, but some compression will still help a lot, if that makes some sense. So if you're at the point where these are like bubbling out and the middle is pushing out and the outsides are squeezed together, that's too much, but you're probably not at the point where you're doing harm. The biggest issue is going to be on your compression jig. If you're starting to bend it, that's the problem. With this type of setup, you really can't get too much. You're going to get to a point where either the angle iron aluminum or the plastic is going to start bending too much, or you're stripping out nuts on the threaded rod. But this is a lot better than having nothing at all. The other thing too is, if you're trying to maintain a constant force and these cells are trying to expand, then that force is going to increase as your state of charge goes up. So at full charge, there would then be more force. So some other members of the community are using springs to maintain a more equal force. This is what I like, and I mean, honestly, if you pick up these batteries, it's not like they're falling out the bottom. So you can tell it's enough force to keep them from sliding against each other. There's not really a gap in there. Now, one thing I definitely want to mention, these right here are some 310 amp hour cells. These are pretty much junk. And the reason why is because these have bulged out ever so slightly. So also this one has shipping damage, but either way, if I were to put these cells together, you can see in here, if you get up close, there's a gap and they kind of rock against each other. You see the gap in there? These could not just be forced together until they touch, because these are not good cells. Now these ones, since they're grade A, they're not bulged at all. You can see I couldn't even stick my fingernail in there or a business card or nothing, because they have nice planar sides that when they squeeze, they're not bulging. I mean, it's simple as that. So one thing I need to touch on before we clamp all this down is the configuration of these cells. Now, these cells are straight out of the box. They have never been bottom or top balanced, nothing like that. They're just as is. Now, in order to top balance cells, and I'll link in a video on this in a card in the corner, you need to connect all of the positives on one side together and all of the negatives on one side. So in this case, we'd put bus bars kind of like this and put the nuts on and charge this until this whole pack was at 3.65 volts in parallel. Now, the problem with that is you need the cells in compression to do that top balance. But then you need to connect them in series. In other words, the positive of the first cell needs to connect to the negative of the second cell. So that presents a challenge. Now, to overcome that challenge, there are two options. You can get some battery cable and crimp up a little cable like this that goes across so that you can drain these down to about 30% state of charge. And then you can remove these and reconfigure the two cells so that you can use your short bus bars for the negative positive configuration. It'd look something like this, except these two cells would be flipped around, and that's how you get 12 volts. But yeah, just something I want to touch on, that you may have to configure these a little bit interesting for your initial top balance and then reconfigure them once they have been top balanced. Now, something that I did just to make things a little bit easier, I had some custom bus bars made that are extra long. I have a bus bar stamping die. So I just stamped these out and they work perfectly like that. And now I have negative here and positive here for 12 volts. And I can still use my normal bus bars for top balancing in parallel. And then I can use these to discharge them the first time down to 30%. and then I can remove them and then take the second and fourth cell like this and reconfigure it and use those other bars. I hope this makes sense, because it's something that is not mentioned in other YouTube videos, that it does play a huge part in the fixturing and compression. One other thing, I have two CATL 310 amp hour cells here, and these same bars that I just showed fitting on this cell, these also fit on the 310 amp hour cells. So if you're interested in getting this size bar, be sure to reach out to us. We'll have our contact information down in the description. I hope that makes some sense, you know, what cell compression is, how to accomplish it, and take my tip on top balancing these. You don't want to bring these up to full state of charge without being in compression. And the other thing you don't want to do is release the compression while they're at a full state of charge.